Let's set up our first cluster. In this video, we're going to be setting up our first cluster using Kubeadm. Kubeadm is probably, not sure about this for certain, but probably one of the most popular tools for setting up a cluster that's production ready. Now, there's other things like Cluster API, which uses Kubeadm under the hood. And obviously then you've got your managed services such as EKS and AKS and the DigitalOcean offering, GKE from Google and all the other people who provide managed services. We're not going down that route, obviously. We're going to be doing everything ourselves. So Kubeadm, that's what we're going to use. That's what we're going to use to set up our cluster. This is going to be the start of a production ready one. Don't use this one in production because it's only going to have one control plane. In the next video, we will add more control planes and that's when it's going to be production ready. Okay, so let's get into it. I'll be doing the majority of this tutorial series in VirtualBox because there's no need for me to do this on physical servers, and it allows people to follow along as they need to and extrapolate what they learn into other cloud environments or physical servers or whatever it is you may need. Now, if you are planning on using Kubernetes in the cloud, there's going to be a lot of differences when it comes to things like load balancers. But in terms of just setting things up, unless you're using a managed service, this should get you going. We're going to start with one control plane node and 3 worker nodes. These have all been set up with Ubuntu using the tutorial that's going to appear down here right now. And essentially the only difference between these and that tutorial is that they don't have RAID and there is no swap partition. So we have a boot partition and a root partition, but that's it. No swap, because the kubelet will moan if you try and set the system up with swap. So I haven't done that. They all have 4 GB of RAM and 2 processors. On the Kubernetes website, it tells us to use a minimum of 2 GB or more of RAM per machine and at least 2 CPUs. So I've gone for 4 GB of RAM and 2 CPUs. Most modern computers should be able to manage this sort of amount, depending on how much RAM you've got, obviously. I have 64 GB of RAM and I think somewhere in the region of 18 threads on my CPU, so I'm going to have more than enough to play with here. We'll go back to VirtualBox. I've started these up so I can actually close this down as well, just minimize it away. And here is my terminal with all 4 machines. So I'm just using tmux here, and there's a little link popping up again to another video that I did that has some information on tmux. And all I've done is synchronize my panes so that I can pretty much run the same commands as I need to across all 4 machines. So we're going to start off just by grabbing Kubeadm. Now there is a website here. I've used this in a previous video to grab Minikube, Kind and kubectl. At the bottom here we've got the Kubeadm install guide. As you can see, again, 2 GB or more of RAM, 2 CPUs, full network connectivity between all of the machines. All I've done is set up networking on here with bridge mode. So all of them are seen as a physical machine on my network at home, essentially. And you need certain ports open on the machines. Well, I've not set up a firewall on this at the moment, and I've not locked down the firewall on this at the moment. Again, we'll do that in more advanced videos, but right now we're just setting up a basic system, and swap must be disabled. So there's a few things here. We need to just make sure that everything's unique. Well, I know they are because we set up separate VMs, and I'm going to move on. I know network's working fine. These ports need to be open. So we didn't do a video in the Linux series on firewalls, but that's because that's going to come probably in a later series that I do on Linux that has firewall information on. We can make sure this works by running this command, but I can tell you now, if you've just installed Ubuntu, this will work. It's fine. It won't lock anything down by default. We now need to install a container runtime. To do that, we need to install containerd, Docker Engine or CRIO. We're just going to stick with containerd for ours. We can install that shortly, and I'll show you how to go about doing that. And then finally, all we need to do is these last few bits down here. So to do that, let's go all the way back to the top and we'll go installing a container runtime. Well, here it uses a container runtime interface and see container runtimes for more information. So I'm going to open that. And in here, we can just go ahead and click containerd. But before I do that, let's just scroll down a little bit, because if we skip this section, the install and configure prerequisites, we're going to be in a little bit of trouble later when trying to run Kubeadm in it. So all we need to do is just run this section here. So we'll start off by running this. I'm going to jump back over to my terminal, copy and paste that in. Let's synchronize our panes, just make sure they're synchronized, which they're not right now. And I'm going to paste that in. So all this is going to do is add some bits into the modules load for Kubernetes. So we'll run that. And if we go back, we can then go and run the mod probes for those. And if we go back, we can now just ensure this works. All this is doing is ensuring that these are configured to 1. They're just kernel parameters, so we're just going to do that. So we'll press enter on that. And finally, apply those just to make sure it's configured and is going to continue on reboot. Finally, we'll just run this. I say finally, not finally, but we'll just run this to make sure they're enabled. So we should see the net filter one and the overlay one, which we do. So we've got BR net filter there and overlay here. And now finally, we will run this here. So this is just verifying that this actually worked and applied everything. So we should see that these are all set to 1, and they are. Something else we need to do is to make sure that swap is off. Now, I didn't install a swap partition on this system, but Ubuntu helpfully adds a swap.image file when you don't put a swap partition in. So we're going to have to make sure that it's off. So if I just open up the FS tab and comment out this swap.image here, you may have one, you may not. If you're using Ubuntu, it's very likely you will have. And finally, just run swap off -a, and that will, with sudo, and that will turn the swap off. Now, if I just write free, you'll see now that swap's 000 across the board. So now we're ready for Kubeadm to run. If you don't do those things, then you will basically have an issue when running Kubeadm. Now we can go ahead and actually install Containerd. I'm going to select Containerd as that's what I'm installing. And it says, here are the steps to use Containerd as a CRI runtime. For instructions for getting started with Containerd, so I'll open that. And we can go ahead and have a look to see how we do this. So we can download it from here. And all we need to do is just scroll down and grab the version we want. In my case, it's AMD64 tar.gz because I'm running it on an AMD64 machine. So to download that to my machine, all I need to do is copy that link address because I don't want it on my computer, I want it on these. Paste it in, put wget at the start, and we'll grab that. So we'll just give that a second for all of these to download Containerd. And then once it's done, all we need to do is run this command to extract it under user local. So I'll run that command now on all the machines again. Before I do, I'm going to sudo up. I'm going to do sudo su just to make sure I stay in the current directory, and then I'm going to go ahead and run that command. Now I'm just going to make sure I've got the right one here, so I'm just going to delete back and then tab. Yeah, I think that version there was 6.2 and I'm 6.15 that I've downloaded, so I just want to make sure of that. And we'll run that. Okay, that's that done. Now if we bring this back in, we can see a little bit of information here, but this is the bit I want to look at. For Kubernetes, do I need to download CRI Containerd CNI version 2? No. The reason being, the CRI feature has already been included in here, and you do not need to download this. Cool. Well, that's fine. I'm happy with that. If you intend to start Containerd via systemd, you should also download the Containerd service unit file. Well, I do intend to start it via systemd. So you know what? Actually, I'm going to open this here, and I'm just going to grab that, and I'm going to go to here and do wget that, and then we're going to do -O, and I'm going to... Yeah, I'm just going to make sure I've got the right location here. So we're going to copy that. We'll put that into here. I think I'm missing the E off the end. I am. So we'll just grab that. So we don't have that location. Right, so we'll get rid of this local bit here for Ubuntu. And we'll dump that in there. Now we should be able to run the next bit of the commands, which is, let's have a look, daemon reload. That's cool. We can just do that. This will reload it. And then finally, we can enable that. And it should just pick up that new system. If I now do... status of that, we should be able to see that it's loaded and active. It's running. It's ready to go. Cool. Brilliant. So that's working. That's good stuff. The next thing we're going to need is these bits. So we're going to grab the runc. I won't get into what runc is right now, but if you want to learn more about it, you can click this link and find out. I'm going to read it now, aren't I? So it's a CLI tool for spawning and running containers on Linux. So we are going to grab that, and all we're going to do is get the right version we wanted. So again, I'm going to get the runc.amd64 version. We'll put this back in here, do a wget, and let's grab the location it wants it in. So I've jumped back over here. Actually, I'll grab it and then put it into that location. So that's fine. So on that, all of them will download it. And you can see why tmux is really useful now. If you watch my previous video on tmux, it's really coming into its own. So we're going to install it with permission 755 into this location. Cool, let's run that. So now we should have runc. There it is. And finally, we need the CNI plugins. So this is the container network interface plugins. And all we need to do for that is grab this. Okay, we'll grab that, and we will do the next command, which is followed by downloading it. So we'll quickly download it. So I'm going to look for the AMD64. Don't need any of the shars. I mean, you can download the shars. Don't get me wrong, I recommend it. It's always good to shar check your downloads if it's available, because it ensures that it's not corrupted. But for speed, because this is already going to be a long video, I'm just going to go ahead and download it and trust that the nice people of the internet are indeed nice. So we'll just wait for that to download on all of them. And while it is, we will go ahead and look at the next command, which is we're just going to extract that into this location. Okay, that should be fine. So let's go ahead and run that. Again, I'm just going to make sure I've got the right version there because the version has changed from 1.1 to 1.2. And let's run that. Okay, there we go. So option 2, well, if you want to do option 2, you can install it from apt. You can do apt-get install containerd.io if you want, or you can, as you may have noticed in previous videos, I enjoy grabbing the binaries myself because it means I'm in charge of updating them and it allows me more management over them, and that's just a preference. It's completely up to you if you want to go ahead and install it via apt. There we go, that's containerd done. So as it said, follow the instructions for here. Return to this step once you've got a valid configuration file. Well, did we get a valid configuration file? I don't remember seeing that, so we'll do config.toml, and let's spell toml correctly. So, customizing containerd. Containerd usually is a configuration file located in this location for specifying level options, blah, 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 blah. The default configuration could be generated via this. Well, I like the sound of default configuration, so I'm going to go ahead and grab that command, kick it into there, and press enter. There is no location. Nope, there probably isn't. So we'll do etc containerd, and then we'll run that command again. There we go. Now if we take a look at that, so actually I'll quick just do this. There we go, we can see how this has been configured. It's just the default. So TOML's a little bit like YAML and JSON. It's just a way of defining things in a certain format, that's all. It's nothing special in that respect. So yeah, there we go. Yeah, I mean, that's the default one. That's fine. So we will probably be configuring that further. Let's have a look. I know we're going to be configuring that further. I'm just saying it like I'm learning along with you. But yeah, here we go. So configuring the system D C group driver. Well, we are using system D, so we're going to use the C group driver. So we need to have a look. So we need to use the system D C group driver in this location, which we've just created, with run C, which we've just downloaded. So all we need to do is go ahead and make sure everything is set up. So we're going to go and have a look for this. So let's open up, let's just do it like this. So I'm going to go down and find plugins.io container d.gprc.v1.cri. So gprc.v1.cri is here. So there might be some sub elements to that. Let's have a look. .runtimes.runrc. Is there a .runtimes? I believe this might be what we're looking for. So containerd.runtimes.runc. There it is. And we need to then inside there have .options. So do we have a .options in there? We do. And if we go a little bit further down, we've got the system C group equals true and as is equal to false. So what we need to do is replace that for true. That was easy. The system D C group driver is recommended if you use C group v2. The question is, do we use that? Well, let's have a look. Okay, here we go. Using C group v2, the recommended way to use C group v2 is to use a Linux distribution that enables and uses C group v2 by default. Check if it uses it. Here we go. So how to identify it? We just go ahead and run this. And we are using C group v2. There we go. Simple. So that's that. We've validated everything there. So we can come out of here and carry on down. So this is just a bit of information about if you installed it from a package, you may find that the CRI integration plugin is disabled by default, whereas we know that it's enabled by default if you use the binaries. Another reason I go for the binaries. So let's carry on down, and we've already run this bit, but we're going to go ahead and run it anyway because we've changed the TOML files. So we'll go ahead and do that. Now, I did actually notice an error in one of the TOML files, so you may have noticed it when I was recording this, but if I look in here, I wasn't paying attention to the other ones, and I ended up changing this section in these two files, not this section as I did in these two. So I've quickly corrected that secretly out of view of you, dear viewer, and now I'm going to go ahead and run that restart command. So we'll do restart, and there it is. Don't need sudo because I'm already root. And everything's up and running. Hooray! Let's just check that with the status of it. Let's put a space there. And everything should be active, 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 active. Cool, okay. Happy days. What's next? Let's have a look. We can overwrite this if we want to. In your containerd config, you can overwrite the sandbox image by setting the following config. Okay, well, I mean, we don't have to do this, but, you know, it's there as an option. Might as well make use of it. For this, we need to find plugins, IO, containerd, gprc, v1, CRI. So let's have a look in there. We'll go start at 0.1 just to make sure that we don't do what we just did a second ago. And we'll scroll down and let's have a look. We have sandbox image. Here it is. There it is. Right. So plugins, IO, container RDs. Yep. Okay. So that's all there. And that's using 3.6. This is using 3.2. We don't need to change that. It's more up to date. So that's fine. Just wanted to check, make sure that everything's as up to date as it can be. There will be probably newer versions since 3.6, but Obviously, this is what works with container D because that's what's downloaded as part of the default TOML generation. So let's continue down. So this section, okay, yeah. So this is using CRIO. We don't need that because that's a different container runtime. So we're happy. We're good. We can carry on. So we can close this. We've done our container runtime. Now we need to install Kubeadm, Kubelet, and Kubectl. Pretty straightforward jobby. We can do it via the package managers or other ways. Well, firstly, we're going to need these. So let's go ahead and run apt-get update on all the systems, and then we'll go ahead and run this to just get some required packages that are needed to run Kubernetes. So just CA certificates curl and apt transport HTTPS. So we'll go ahead and run that once update's finished, which it already has. So we'll go ahead and install them. And while that's installing, we'll look at the next bit. So we can download the Google Cloud public signing key. Okay, let's go ahead and do that. And I'll run that. So there we go. That's downloaded. And okay. Oh, okay. So this is to install it via apt. So yeah, if you don't want to install it via apt, you can just go ahead and run all these commands. I am going to install Kubectl and Kubelet and everything else via apt at the moment, purely because, yes, I could get the binaries, and I know I've said multiple times I prefer to get the binaries, but in this one case, I can run it via apt and it's fine, it would work, because what we can do afterwards is we can hold the packages. Now, we could do this with all the other packages, we could have done it with container D, but I'm just kind of mixing up my instructions here, really, that's what's happening. So you can do it via binaries, you can do it via apt. Let's pretend what I'm actually doing here is showing you multiple ways of doing this. So yep, I'm going to do this bit via apt. So let's do that. And yep, that's done. Next, we can do apt update again. And the thing is, by installing this via apt, we're actually doing it via the official channels. So I know that I'm always going to be able to get the latest version without having to worry about anything else interfering, essentially. So that's fine in my opinion. I'm happy to do that. So we'll go ahead and install the Kubelet, which is responsible for making containers real, essentially, on nodes. Kubeadm, which is responsible for creating a cluster, and Kubectl, which we've already covered, is responsible for interacting with the Kubernetes API. So we'll go ahead and install those things now, and we'll look at what's next. The next thing is to mark the packages as held. Holding a package basically means that when I run apt update and then apt upgrade, it won't upgrade these three packages. I'll have to physically run apt get install these three packages again to install the next version. So we'll just wait for those to finish. Okay, that's done. So the next thing to do is mark those as held. There we go. All of them have been marked on hold. That's cool. That's what we wanted. So we can move on to the next section. Configuring a C group driver. Well, we've already done that, so we don't need to worry about that. Cool, that's it. We've got all the packages. We're ready to go. Let's go ahead and create a cluster with Kubeadm. So let's have a look at what we need. We've already been through a bit of this already. So minimum requirements there, we already have. Preparing the host, well, we already have the container runtime, so that's fine. And yeah, we're pretty much ready to go. So initializing your control plane node. So this is the machine where the control plane components run, including etcd, unless we set it up as an external one, which is for another day. And yeah, so basically what we want is a control plane setting up and then add some worker nodes to it. Now, if we want to think ahead here and consider the fact that we are going to want a highly available control plane, which will be done in the next video, we're going to need to consider a control plane endpoint. If we were in the cloud, we could do that and it'd be fine and it'd be the IP of a load balancer. We're not in the cloud. We are setting up on our machines at home or wherever you may be doing this. And yeah, we're going to need to set up a control plane endpoint somehow. Well, thankfully, a nice chap called Dan that I know invented this, which is KubeVIP. And KubeVIP is basically a tool that allows us to use a load balancer out of the cloud, essentially. So it gives us an idea of how we can set things up, like control plane endpoints using Kubeadm. So we need to generate a KubeVIP manifest in the static pods manifest directory. See generating a manifest section below. Now what this is when Kubeadm runs, it will generate some static manifests for the Kube API server, the scheduler, the Kubecontroller manager, and it sticks them all in etc Kubernetes and manifests, and the Kubelet knows to generate pods, static pods based off that. Essentially, that's what it is. They're not deployments or anything like that. Kubernetes can't do much with those pods in terms of scaling and things like that because it doesn't really know about them in the context of Kubernetes. It just knows to spin those up. So we need to do this as part of the setting up of Kubeadm. Now, if you're not worried about high availability, which you should be, then you can just go ahead and skip this section but I recommend you do this section because if you don't and you decide to add more control plane nodes later, you're going to have to set up an external load balancer to manage the traffic going in. In fact, what you're actually going to do is you have to reconfigure the cluster because you won't have this control plane endpoint flag defined and ready to go. So let's go down to generating a manifest. So in order to create an easier experience of consuming the various functionality within KubeVIP, we can use the KubeVIP container itself to generate our static pod manifest. We do this by running KubeVIP image as a container and passing in the various flags for capabilities we want to enable. So how do we do that? Well, let's just go and start doing this. So we need to set up a VIP. I'm just going to use a IP off of my network that I know is free. If I run IPA on all of these, I have this one starting at 201. This one here is 211. This is 212. This is 213. I've done that because it means that here I can do export VIP equals 192.168.0.200. That's what I'm going to use. You can use whatever you want, just make sure it's an IP that's free and will not conflict on your network. Then I need to export an interface name. So my interface name on here is EMPOS3. So I'm just going to go ahead and copy and paste this in and change this to EMPOS3. And that will do that. And this is the interface on the control planes, which will announce the VIP. This will need doing on all of the control planes, but for now, this will do me just fine. Now I need to get the latest version of KubeVIP. So we'll just go ahead and copy and paste this in. I should be showing you what's going on here, but basically all I'm doing is going through this section of set the configuration details. Don't worry, I'll set a link to this in the description below. So if I'm talking about anything and I don't have it on screen, then you'll be able to follow along using the website because I'm going to keep dragging it out of the way like this. So we're going to go ahead and do that. And I've not got JQ installed. There we go. There's something I need to do. So let's just quickly synchronize those panes again. Now remember, we only need to do this KubeVIP stuff on the control plane. We don't need to do it on the other nodes because they're not control plane nodes. This is why I'm not synchronizing my panes anymore here. Okay, so we'll go to the next section, which is we're going to create the manifest now. What we're going to do is for containerd, run the command below. Well, we are using containerd, not Docker, so we're going to go ahead and do that. So we'll just double check, make sure this is all making sense. So CTR is the containerd command line tool for pulling images down. There is also Docker pull. You might have seen that if you use Docker. If you haven't, then welcome to the world of containers. So we'll do that. And what we'll do now is come down and grab this section. So we are going to be using ARP because I don't have a BGP router at home. If you have a BGP router, then you'll know what you need to do with that, I imagine, because you're using BGP. If you don't know what you're doing here, use the ARP one because ARP will be the default way of running things just on a home network or something like that. So what we will do is, I'm not going to read all of this out to you, obviously. What I'm going to do is come down and grab this here. So this is KubeVIP manifest pod. It will create everything it needs to with all the flags, and then it will dump it into this manifest file. Okay, at this location I might as well. So what we're going to do is just make sure that location exists with make directory, and it already does. That's fine. Okay, we can continue. So we'll run that command, and that will go ahead and pull that container and run it essentially with the manifest file. Well, it won't run it. It will create the manifest file using KubeVIP, and we'll have a look at it afterwards, but it should look something like this essentially. That's what it's saying. So we'll just come back up to the top here. We've generated our manifest. So as it said, generate a manifest, see below. Then we need to go ahead and run Kubeadm init with the control plane endpoint flag using the VIP we provided. So we'll just give that a minute to run. There we go. It's just finished, it turns out. So here's the manifest that it's output. So yeah, that's going to be fine. We've passed all the environment variables in, so we'll get all of these bits like the IP address that we passed in and everything else that we set. So cool, that's up and running. What we will do now is just make sure we pay attention to this document as we go through. So let's just read it through real quick, just to make sure we know what's going on. So we're going to run Kubeadm init with the control plane endpoint flag. That will use the 192.168.0.200 IP address that I just typed in. The kubelet will then pass and execute all of the manifests, including the KubeVIP manifest generated in the step above that we just did. So KubeVIP will then start and advertise the VIP address, and then the kubelet on this first control plane will connect to the VIP address advertised in the previous step. Kubeadm init finishes successfully on the first control plane, and then using the output from the Kubeadm init command on the first control plane, run the join one on the remainder of them. But we'll be able to use the VIP across on everything else essentially. So we'll be able to point all of our worker nodes and things like that to the VIP. We also just need to copy the generated VIP manifest, as it says here, to the remainder of the control planes as we create them, which we'll do in the next video. So don't worry about that for now, unless you're doing it now, in which case, good job, you're jumping ahead. All you need to do is make sure you follow this step here. I'm going to go ahead and jump back to this one here. So recommended if you have plans to upgrade this single control plane Kubeadm clusters, high availability, you should specify this flag. Hey, we can do that now. So that's cool. So let's start typing this in. Kubeadm init control plane endpoint. Okay. And that control plane endpoint is going to be 192.168.0.200. So the next thing we need to do is choose a pod network add-on and verify whether it requires any arguments to be passed to Kubeadm init. So usually here I would just say, right, let's head over to Cilium and we'll install that, okay, which is great. It uses eBPF, which is quite old, but an amazing thing that's growing, becoming more popular, should I say, not growing. And Cilium have based their pod network interface on this. On eBPF, and I won't talk about eBPF now because it's a massive thing. There is a little bit of setup you have to do around it, and it's good to know a little bit about how it all works before jumping in with it. So for now, we're not going to be using Cilium. You can set it up pretty quickly and easily, but I'm just going to go for the more popular, if you like, and easier option for now. However, in my video where I do the highly available cluster with etcd separate, I will put Cilium on there. So if you're interested in that, check out that video when it comes out for Cilium and I'll cover it there. For now though, we're going to want Calico. So Calico Kubernetes, yeah, go on then, let's refine that search. I'm just going to use the default settings basically. So if we have a look, this should be somewhere around here. You just have to do the self-managed on-premises one. And yeah, we'll go on to that one. And it basically just says how to install it. You can use an operator or a manifest. I'm not even going to go for the operator because that'd involve explaining what an operator is now. And we're not going to do that. So all I need to do is grab that. Let's go ahead and do that. So let's just... I've just pasted that into there. Let's just comment that out for a second. Yeah, okay, so we'll grab that. We've got calico.yaml ready, and we'll just make sure if you're using PodCider, yeah, skip to the next step. If you're using a different PodCider with Kubeadm, then no changes are required. So it'll automatically detect the cider based on the running configuration. Cool, okay, so we don't need to pass any extra ones in. That's what it's telling us there, basically. So obviously it was saying if you need to pass any pod network ciders in. So I've got a note right here saying explain PodCider. So a pod cider is, well, okay, let's get into what a cider is first. So a cider is a classless inter-domain routing or supernetting.
Is that it? Or
Brilliant, right? So it's a method of assigning IP addresses from a block of IP addresses. There's more to it than that. I'm not going to get into networking right now, but you might see something like 192.168.0.0/24. That /24 means that you have 256 IP addresses available, and a pod cider is the one that the pod uses, okay? So your home network probably has the one I've just said, or something similar. If you want the pods to have a network, well, we need to provide a cider to it. So you might see something like 10.65.0.0/16 or something like that, which gives it a lot of IPs. I don't know how many off the top of my head, possibly 65535. Genuinely don't know if that's right. I would have to actually Google that because I don't know. I probably should know, but I don't off the top of my head. So what this is it's the network for the pods to use. It's not a network that you need to be able to access or anything else needs to be able to access. No machine or human or anything else should be able to access those IPs. Only the pods should be able to access those IPs. So, you know, let's say you've got 10.65.0.0/24, okay? You have pod 1 come up on 10.65.0.1 and another pod come up on 10.65.0.2. Only those two pods should be able to access those IPs. So pod 1 would be able to hit the 10.65.0.2 and pod 2 would be able to hit 10.65.0.1. That's kind of what it is. It's the network the pod uses. The services also have their own cider, so the SVC or service in Kubernetes that sit above the pods that act as load balancers for the pods. Again, we'll get into all this later. They also have their own ciders. So that's what a pod cider is. That's what a service cider also is. And we define them as part of the cluster. We don't have to define them. They are automatically generated if you don't. But if you need to define them, you can. and that's what a pod sider is. Now, if you want to change your pod network sider, that's fine. But, you know, again, that depends on your networking setup and things like that. Basically, it's the network the pods will use. So I'm happy with that. Kubeadm tries to detect the container runtime. Well, that's fine. It will pick up the containerd runtime, so we know that's fine. And it uses the network interface associated with the default gateway, which I've only got one network interface on my machines, so I don't need to worry about that. You know, if you've got more than one and it's not the default, then, you know, you need to consider that. So I'm happy with what I've seen so far. Everything's fine. I've done this. I'm not bothered about this. I'm not bothered about this, and I'm not bothered about this. So we're going to move on. I could do IPv6, by the way. It does say here that I can use IPv6, and I could do that now, but I'm not going to get into IPv6 now because it, again, just involves a little bit more setup that we're not really interested in today. Okay, so considerations about this. Yeah, well, what this is essentially alluding to is setting up a DNS record. Well, I haven't got a DNS record on a DNS server available. So what we can do though is we can set up a record in our host file of 192.168.0.200 in my case for the VIP, and call this Kube API server. We'll just call it that, okay? And I'm going to go ahead and do that. In fact, what does it say here? Just control plane endpoint, cluster endpoint. So you can call it cluster endpoint. You can do whatever you want with that, as long as it's something that can resolve essentially. So if I just do ping Kube API server. Oh, ping's not found. Okay, let's synchronize our panes. I believe what we need to do here is apt install IP utils. If I remember rightly, IP utils ping. Pretty sure that's what it's called. Yes, there we go. And unsynchronize my panes. And ping Kube API server. Now that is a DNS resolution, so it's resolving to this. Obviously it's not going to work yet because I've not actually set anything up yet, so that's fine though, it resolves. So what that's saying here is that I can go ahead and define the control plane endpoint as this DNS record, and it will also have the advertiser address being my node. So for example, this is the IP address of the node, and cluster endpoint is a custom DNS name that maps to this IP. So the reason it does this is because you cannot modify something that hasn't been defined with control plane endpoint into a highly available cluster. So that's why it's recommending this. You could later change that IP and it would work. The reason being because it generates certificates that allow certain things to be able to connect. Okay. And by doing that, it means that everything would have to be regenerated. And that would involve basically respinning the cluster or manually recreating certificates and things like that. You just don't want to get into that. Okay. So the reason it's recommending this DNS option is to get around that problem. I've got a VIP because I know I'm going to be using that. I'm still going to set that DNS in case I decide to change that VIP later down the line. So let's go back to our Kubeadm init command. And in here, I'm going to set the API advertiser address for this particular control plane API server. So this is this node's API server. And I'm going to set this to be 192.168.0.201, which is my node's IP. So this is the node IP. This is the VIP that KubeVIP will set up. Okay, so quick note right here. I'm actually using the IP for the control plane endpoint, the 192.168.0.200. That is technically wrong. Now you can use it and it would work. It's not a problem. But if that IP changes at a later date, then you will no longer be able to access your cluster, even if you change the IP in your kubeconfig. The reason being is that IP or the control plane endpoint flag, the value in there will be encoded into the certificates that are generated when the Kubernetes cluster is spun up. Now, if the IP changes and you change it in your kubeconfig and you've used it in the control plane endpoint, when you access your cluster, you'll just get an error back saying that the IP does not exist in the SAN or whatever error it might give in terms of it existing in the certificate. That means you'll no longer be able to access your cluster unless you use it from the control plane node or something like that, which is obviously not ideal. So here, change the control plane endpoint for the value we put in etc host. Was it KS API server or something like that? I can't remember off the top of my head without digging through it. And that means that IP, that domain, is pointing to the IP. If that IP changes, we can point the domain to the new IP. And because it's the domain that is encoded into the certificates, it means that any IP changes won't be problematic for you. They won't cause any issues. Okay, so make sure you change that control plane endpoint for the DNS. I will be doing it later, and I do correct that, but I don't think I say it in the video. So I thought I'd just interject here to tell you to do that. Okay, so there's a little bit more information here. So you can see things in the Kubeadm reference guide. We can also use a Kubeadm configuration file, which again, I'll talk about in a later video. For now, we're not going to be using it, but essentially it means we can set up a config file with a lot of the information in that we're going to put into flags at the moment, and then run it against that. We're kind of hitting the bottom here. You know, we're at the install pod network on now, which we're going to do in a second. So let's carry on, because the next step after this will be joining our nodes. So let's go ahead and hit enter on this. And Kubeadm should now initialize the cluster. So we'll give it a few minutes because it now needs to pull the images. Okay, and there we go. That's it. The cluster's up and running. If you did get an error, there's a good chance something somewhere went wrong in terms of the way you followed along. Sorry, that's just the reality of it. If there is a problem, you can check things like the logs for the kubelet to see if there's something going wrong there. Alternatively, you can just run kubeadm reset and then try and run through the process again. Now, we have some guidance here. Let's have a look first. So to start using your cluster, you need to run the following as a regular user. Okay, well, that's going to move our kubeconfig from this location into our normal location as shown in the previous video. And I'm not going to go ahead and do that at the moment because I'm root. And to be honest, I can just use the ---- kubeconfig to reference it. Alternatively, I can just set this for now, which is exactly what I'm going to do. So let's just run that. So now my kubeconfig's been set. I don't have to move it into my root location. And now it's telling me that we should deploy a pod network into the cluster. Well, it's funny you should say that because I actually already have one. Here's that list I was talking about earlier. There is a list. I think I was talking about it earlier anyway. I should have done when I said you could have a look for them. And here's a massive list of them. There's plenty of them. Calico and Cilium are probably two of the most popular. Flannel's pretty popular too. I have used one called KubeRouter, something like that. And yeah, it was all right. It was pretty good. I don't know if it's still a thing, actually. I'm not seeing it in here. So maybe it wasn't that good after all. I don't know. I can't really comment on it because I was really new to Kubernetes when I used it, and I saw it and went, well, that looks like it should be good. It's been built for Kubernetes rather than to support multiple different things, which is, to be honest, what some of these have done. You know, they're from other areas of container networking, and they also work with Kubernetes. But yeah, Calico and Cilium are pretty up there as top ones in my opinion. Canal's pretty good as well. You can see here it unites Flannel and Calico. Yeah, so there's multiple reasons to pick a particular one. Have a read through these, see if there's one that suits your needs better, and if it does, use it. You know, Amazon have their own, so have a look. I'm going to use Calico. We've already said that. I'm going to go back and just install that. So it says here we can run, what was it? kubectl apply -f for file, and then the pod network.yaml. Well, we already have one, so we'll do kubectl apply f Calico, and we'll do that. It will install a bunch of custom resource definitions and cluster roles and a daemon set and deployment. So let's go ahead and get that stuff. Yep, that's all there. So the pod disruption budget's coming up. They will come up once these are in place, up and running. So I'm going to do kubectl get pod in the kube system namespace, which is where everything's deployed at the moment, and just see what's going off over there. So Calico's coming up. We can see it coming up. Things like the core DNS won't come up. These will stay pending until Calico is online because it needs the networking to be online before core DNS can come up. So we'll just watch that, make sure that comes up. And yeah, there we go. It's up and running by the looks of it. So the other good thing to note is that means KubeVIP's working as well, as it should be doing. So if I go ahead and look at the kubeconfig real quick, we'll look at Kubernetes, and it was under admin.conf. We'll see that here it's using the VIP, not the node IP. So that means that's working. That's good news. And I actually should have done an init on my when I run the Kubeadm init. I should have changed this for the value I put in the host file. So thankfully this isn't my final cluster, otherwise I'd have to do a reset and a restart of this. But yeah, so really this should have been the value I put into, what was it, Kube API server or something like that. So that's what I should have put there. But it doesn't matter now because I'm going to be killing this cluster soon anyway and resetting it. So let's scroll back up to that output we got. And all we need now is to join any number of control plane nodes by copying the certificate authorities and service account keys on each node and then run and follow in its route. Well, I'm going to go ahead and take a copy of that, and I'm just going to dump that into my Sublime because I'm probably going to need that when I do my next video. What I do want to do now though is I want to join any number of worker nodes. So all I need to do, I wish TMUX would stop doing that, I need to change the settings, is grab this command here, and then I can go ahead and run it on all of the worker nodes. So if I copy that, and the first thing I'm going to have to do, again, just to make sure it works as it should, is I'm going to have to set W, synchronize panes. I'm going to do vim etc hosts, I'm then going to just quickly go ahead and unset it and delete that line. And then we're going to reset it because I'm just going to put it in again, but I need to put it on all of the nodes. So 192.168.0.200, and that will be Kube API server. So there we go. That's fine. I'm going to paste that in there. Unsynchronize my pane so I don't have to manually paste it into 3 different ones. Get rid of it off the control plane. I'll then synchronize my panes again, and let's just check. So we've got Kubeadm joined, the IP address and the token, the discovery token, and we'll click enter. So now all of these 3 will start joining the cluster basically. So if I do kubectl get nodes watch, we should see those 3 clusters appear into this output here. So they'll come up as not ready first because the kubelet will be up and running and starting up and all that good stuff. So we'll give it a few minutes. And there we go. We've got some starting to become ready. So it should just take another few seconds and the other one should become ready as well. And again, this is evidence of the VIP working as well. So I'm just going to restart that watch because it's getting a bit messy. And there we go. We have all of our nodes ready, good to go. Brilliant. We've got a cluster. That's it. That is your cluster set up and running. Now all the nodes are ready. We can do kubectl get pods in the kube system namespace. Sorry, that's my alias, which I will show you later. But for now, let's check this out. So core DNS is running. So that's good. That means the pod networking Kaliko is running basically. It means it's up and running. And for every new node that gets added, a new Kaliko node pod gets deployed because it's a daemon set. So that's it. We have a cluster. And that's it. We've got the first part of our cluster set up. We've got a single node for the control plane and 3 worker nodes. We just need to add a couple of extra control planes to this, and this is essentially production ready. However, you would need those firewall rules to, protect each of the nodes and the services on each of the nodes from potential attack. But in theory, this is now production ready. I will talk about firewall rules and everything in a later video, so don't worry about that right now because that's not what we're doing. We're not setting up production clusters today. We're setting up clusters that could be used in production. So if you want to learn about firewall rules, then I'm going to stick other videos up later about how to do that in Kubernetes. I'm also going to be doing more on my Linux series in terms of adding additional content essentially to that. And one of those things will be IP tables, firewall D, things like that. Okay. But yeah, here we go. We've got our first cluster ready to go. We can use that now. It's just not very highly available. So we'll make it highly available in the next one. I'll see you over there.